Okay, so it's 2 o'clock. Can everybody hear me just fine? Great. Okay, so this is CIS 1051, unless I've made a horrible mistake. I'm in the complete wrong classroom. So this is 1051, right? Okay, great. Something that I'm always worried about, to be honest. Let me introduce myself. I'm Professor Andrew Rosen. I teach CIS 1051 as well as not the next course, but the course after that, CIS 2168. I'm also the advisor for the data science program here, as well as the advisor for the computational masters in computer science, computational data science masters, the computer science bachelor's master's accelerated program, and the computer science math dual degree program. So if you've got questions about your degree, if I can't answer it for you, I generally know who to send you to ask about that. So if I don't know your answer, I can help. If you don't know the answer to something, I can help you find out. For those of you who are in here, let me just kind of tell you who this class is for. I mean, I've got it on the Canvas page, but reading's hard. So, but this class is basically made for everybody. It doesn't matter if you're here as the first step for getting a computer science, IS&T, data science, or any of those related degrees. It doesn't matter if you are a senior here trying to get some computer science in right before you graduate. It doesn't matter if you're just somebody who's curious about this and wants to take a course. This class is designed for you. I made this class to cater to basically as many people as I could. So with that said, that means there are various students of a lot of different backgrounds in this class. There's even some students who probably taken who've already taken something of this level and just want to take this because they want to learn Python and get credit for it while they're learning Python. So there's a whole variety of levels of people in this class. The worst thing you can do if you're just starting out is compare your progress to that of other people. Only progress I care about is yourself to yourself. So keep that in mind. It's very easy to get demoralized by seeing what other people know versus what you know. Don't make that mistake. So this first day, I typically like to go over the syllabus and go over a brief history of computer science. This is generally because there's a lot for us to basically do in the first week, and this first day basically gives us a baseline. Your first lab, what we're going to do is basically make sure that you have the tools you need to program installed on your laptop if you have one, or you know how to use the tools on lab computers. I highly recommend getting a laptop. If you cannot afford one, please speak with me. We can look at various options. That shouldn't be a huge impediment, but it will be an inconvenience. Won't be so there's a difference there, right? So I highly recommend getting a laptop, specifically one that you aren't going to get angry every time you use. I've had to work with a couple of those myself, and that's just not fun. So on Thursday, we will do an exercise from our textbook called Look at the End Goal, which will give you an idea of the various tasks we can do with computer science. But let's go ahead and jump right into the syllabus. So first off, if I'm sick, right, so if I'm sick, or I've got a kindergartner now, so I mean, like, it's going to happen at some point. If I get sick, or I've got both my wife and kids sick, and I'm most likely sick, but not as sick as them, I will just simply hold class via Zoom. I'm not going to cancel class unless I'm really sick. I might hold class via Zoom. Similarly, if we get a terrible snowstorm, same deal. On the flip side, as I mentioned, if you are sick, don't come to class. I've got Zoom up and running right now. Already had a student tell me that they had to be out. So feel free to join via Zoom if you need to, or watch the recording that I do later. Or if, the road conditions aren't safe for some reason. you know, I'm fairly reasonable about this. If you can't make it to class for any other reason, I assume, since you're an adult, that it's a good reason, and you don't really have to go into detail about it. Just let me know. Okay. I try to make this class flipped, which means that I give you textbook readings and videos to watch as your first exposure to the material. And then in class, we do exercises from the textbook. These projects, this textbook is great for that. The labs are held in person unless otherwise specified for the same reason. The syllabus has, and the front page has the important links, specifically the link to, I probably have to update that link, the lecture recording link, but the Zoom link from this lecture, the Discord link. For those of you who don't know, Discord is essentially like Slack. It's just a giant chat room. And lecture recordings, they're on the front page of Canvas. The other part to know, as I'll talk about later, submitting your homework is a two-part process. So your lab assignments, your homework, that's a two-part process where you submit your assignment. That's step one. That's how we know whether it's late or not. And we do accept late work. I'm a big fan of late work. But that's the first step. The second step is to demo your homework, meaning come to me, come to a TA, any TA, during their lab or during their office hours or during my office hours or after class, and just show me that it works. And I might ask you a couple questions about it as they get more complicated, but that's how you check it off. Which leads to the next point. Uttering some variation of, I didn't know we needed to demo our assignments to receive credit for them, is an automatic 0 in this class. I used to get that a lot, and ever since I put in that clause, nobody says it anymore. So, you know, it works. But seriously, reading directions is a very important thing in this field. So the next thing is to know is you want to sign up for the textbook at runestone.academy. I believe that is still runestone.academy. And you'll want to sign up using the course name Spring 2023 Rosen. It's both in the syllabus and on the front page. This is a free textbook. You should, it is open source. So, and I like it because it allows us to it allows us to execute code inside the textbook itself. It's a great resource that has great projects. The only thing to be aware of is that when you sign up, you want to either use your TU email. You want to make sure that one of these things is true, either using your TU email, so TU XXXX, whatever it is, not your alias, just that weird random number letter combination that you get, and use the name that's listed on Canvas. This is because I use a script a Python script of all things, to merge the Runestone gradebook with our actual gradebook so that I don't actually have to go through manually. And if that happens, it might skip you over, and it might take a bit for me to update it because I'd have to pull it in manually. When signing up for office hours, make sure you sign up with the person you want. I'll go into that in a bit. Don't cheat. I have submitted 51 charges since fall 2022. Most of those were during COVID. And most of those when I couldn't directly proctor people. And so people thought they could get away with cheating on the final by using the internet. Turns out, no, you can't. Pattern matching is a subdomain of computer science. So don't cheat. And when in doubt, cite your sources. At least then we're not dealing with plagiarism. At least then the worst they can go to you is tell you to do it again yourself. We'll get into more what is cheating and what is not cheating. I'm very reasonable about this, okay? And finally, again, I've mentioned this, don't come to class if you're feeling sick, even if it's an exam, okay? I will find a day and a time for you to make up that exam. Because those exams are supposed to be accurate assessments of your skill. It's not going to be accurate if you're sick. Also, you're going to get everybody else sick, and that just seems mean. So, all right, course details. I already explained what this is. It's a 4-hour credit-hour course. To succeed, that means you want to spend about 8 to 12 hours of coursework every week. on this. The general rule of thumb for I'm serious, the general rule of thumb I'm always told for courses is that for every credit hour, you should expect to work somewhere between 2 to 4 hours outside of class. I've heard 2 to 3 and I've heard 3 to 4. So I'm just going to say 2 to 4 hours outside of class. So the only way, this is because it's kind of like music. If you've taken a music course, then you know the only way to get better at the only way you can get better at playing an instrument is by practicing. Similar here. The only way you can get better at programming is by practicing and making the mistakes that you need to make so you know not to make those mistakes again. And if you fall behind because of that, it gets hard to catch up. If you do start falling behind, just let me know so I can work with you to catch you up. It's my job. Don't feel embarrassed about it. It happens to everybody. Okay. Time and place, we found it. Your labs are on either Monday or Friday. Some of you share the same room, which is cool. Please attend the lab you have signed up for, unless you have spoken to me otherwise. This is because there's only so many seats in a lab. Okay. Prereqs, you've needed a C or better in Math 1021. I also expect you do know how to use a computer. So a reliable laptop is strongly recommended, especially since we're using an online text. Mentioned that basically if you're using a laptop or a computer where it's painful to use it, you will suffer physically, mentally, emotionally, and academically. Torment, lamentations, wailing, gnashing of teeth, any other kind of biblical thing you want to come up with there. Yeah, not too great. That being said, there are various resources here. For instance, there are laptop kiosks in various buildings. I believe there's one all the way over there in the College of Engineering over there, where you can just use your card to swipe out a laptop and borrow it. If you can't, there's various resources that I've linked here. If you cannot afford one or you're working on a limited budget, please let me know. I will find a solution within your budget. If we're working on Zoom, headphones, webcam is less necessary. I don't really need, if you don't want to show me your face, you don't have to. It's that simple. All right. So again, here's the textbook information, Foundations of Python Programming. You get that by signing up with this code for the course. Again, it's a free textbook. That just simply enrolls you into my course. Okay. If you need an additional reference, like because you are a person who needs hard copies of textbooks, here are 2 other online free textbooks: Automate the Boring Stuff with Python, Think Python, How to Think Like a Computer Science. These are both available free online, meaning they can be printed out. And they also have hard copies for like 20 to 30 bucks on Amazon. Not like normal textbook prices, but actual reasonable what you would actually think, okay, yeah, I could pay for that prices. And of course, Python also has its own documentation and tutorial. Feel free to look at those. Okay, let's talk about office hours. Below me and each of the TAs, you will find a link which will lead you to this page, which is also embedded right over here inside our own web page. I do office hours this way generally. We've each slotted time. So what you do is just simply select 10:51 if you want to meet about 10:51. If you want to meet about stuff outside of 10:51 and ask me those kind of questions, just select general advice. And then, let's see. Ooh, did I select AM to PM? I must have selected a really weird time for myself. Okay. I'll have to fix that, but whatever. Point being is that you can select who you want to meet with on certain days, and you can select their times. The TAs are busy letting me know what times they have office hours at, and I'm busy figuring out mine. Generally, my office hours will be Tuesday evening and Thursday morning. And these are just times that are open that you can sign up for, okay? Without having to like coordinate with me in advance. I might open up more slots as the semester goes on if I deem it necessary, but that doesn't mean these are the only times I'm available to meet. If these times don't work with you, send me an email, send your TA an email, and we will find office hours outside of that time. Zoom's great. Zoom is great for this kind of thing. So all the office hours all the office hours for 10:51 are conducted via Zoom unless otherwise specified by your TA. So that makes it just really easy for me to meet over the weekend and that kind of stuff. So if you're having trouble, again, reach out. The only thing you want to be aware of is definitely select who you want to meet with. If you select anyone, you may not know who you are signed up for. So, and that can lead to a bit of difficulty figuring out whose Zoom room to choose. Okay. But all the information for each TA and myself are found below our faces on this. Okay. Again, here's a link to the textbook if you can't find it, as well as the code, as well as these instructions. And then I got to fix this link. Again, I've got some minor constructions that I've missed, but for the most part, this course is ready to go. Okay, attendance. I expect you to attend. I mean, you're paying for school, might as well, you know, get your education's worth out of it. If you can't make it, like I said, I assume you have a good reason. If you're sick, just let me know. That way I can know whether or not I need to pay attention to whether or not you're falling behind. Same with the labs. Again, if you arrive late, just, you know, don't make a big deal about it. If you're sick, don't come to class. If you miss an exam, email me so we can make it up. Don't come to class. Okay. Mental health. Similarly, if you experience stress, worry, changes in mood, problems eating or sleeping during the semester, whether it's because of my class or some other class or some other factors, let me know. So, because the sooner you let me know, the sooner I can work out alternate deadlines and accommodations for you, the sooner I can direct you to resources that can help, the sooner that I can actually, you know, help you. At the very least, I can listen. Okay. Because I know from a lot of students have come to me and have just talked. I mean, I'm not a psychologist by any means, but I will be there to give you suggestions if you're having trouble in this class or if you feel like you don't belong. Okay. Disabilities. If you have an accommodation that needs to occur, whether it's because of a disability or not, well, if it's disability related, let me know via DRS. That's the typical way to do that. Also, if you have a religious accommodation that needs to be met, let me know. You know, I don't necessarily want to make you have to, you know, come in and take an exam during a holy day or something. That seems like a not cool move. So please just let me know. I will be recording all my lectures. You can find all the lecture recordings either by hitting this button over here, the lecture recordings over here, or by hitting this one over here, lecture recording. They bring you to the same place. Currently, and as it says, this is an embedded playlist. To access all the recordings, you click on the top right, or you click on the top and it will bring up the lectures, or you click on the top left. Yours playlist isn't up yet because we don't have one, but this is last semester's. And then once that's up, this one will go down to the underneath the previous semesters where you have access to all the lectures from the previous semester. All of them. So I do host them on YouTube, and I do my best not to monetize anything. I would find it highly immoral to make money off of stuff I force you to watch. That seems like just not cool. So I highly recommend, I don't know if there's ads or not, but I highly recommend installing an ad blocker like uBlock Origin or something like that on your computer. If you're not sure what that is, I'd be happy to walk you through that, but it makes YouTube a much more pleasant experience. Not having to deal with ads every so often. But the reason I do put it on YouTube is that I know that YouTube works on every single device out there that you'll be using. Okay. If you do your own recording, you got to let me know. That's just school policy. It's also, I believe, law in Pennsylvania. It's a two-party recording consent state. So two-party consent state for recordings. So you got to let me know. Also, again, it's the school policy. So grading, what you probably care about here. So the letter of grades will be assigned. Let's see. Did I talk about the exams here? I did not rework the exams. Okay. So I completely forgot to rework this portion. So if you read this, the part about the exams, it's probably going to be different this time around, but whatever. Okay, so I have various different categories that will be listed on Canvas, and it's not too much to worry about. It just comes down to basically what deadlines things have. Are they soft deadlines? Are they firm deadlines? Or are they hard deadlines? Right? So solo exercises and classroom exercises. Basically, if it's a classroom or a textbook reading or a textbook exercise, it goes under one of these things. So solo exercises, in other words, doing readings of the text in the textbook, that's about 10% of your grade. It's an easy 10 points in your grade. Similarly, with doing the exercises from those. They are fairly short, they're targeted, and you are free to collaborate with your other students. If you turn in the same answer for the solo exercises, I'm not going to care because it's just the textbook exercises. You're trying to work through this and make sure you understand it. The entire point of this is to make sure that you keep up to date with the work. The due dates for the solo exercises are soft, meaning that they will have a due date, but I'm not going to care if you make it by the due date or not. The due date is there so that you know whether or not you're keeping track, if you're on track. Make sense? Right? This is a recommended completion by. That is what it means. If you've completed by the very last day of the semester, you will get credit for it. That is the way it works for the solo exercises. Similar for the classroom exercises. Those are class exercises we do in the classroom. But again, like I said, you might miss class because stuff or illness. So, you can, again, the deadline for those is soft. You want to do those, ideally, you'd be doing the classroom exercises the same day and turning them in at the end of the class. And because as we work through the exercises in classroom, I am giving you the answers. Okay. So, but if you miss class or just have to leave early or something like that, again, as long as you get it completed by the end of the semester, you'll get credit for it. These are soft deadlines. Okay, the lab/demo assignments, these are what are considered traditionally homework, in computer science, basically it's a project every week that you do in lab as well as kind of as homework. If students are struggling, now the big thing, these are mostly relegated to lab, but if you're struggling with these, then I will divert my normal lecture plans and go over these in class to make sure. So this is where having an open dialogue with me is very important. If you're struggling, I'll check in with the rest of the class to make sure, hey, is this something that a lot of people are struggling on so that we can target these pain points, okay? But these are lab demo assignments. They are 25% of the grade. These are the assignments that are intended to be started on and substantially completed in the lab period, if not completed outright. They are supervised by me or the TA for the introduction. Getting help from your fellow students is highly encouraged. And most importantly, your code must work and be demoed and explained to get credit. These are firm deadlines. Late assignments are accepted. We have a penalty of 5 points per day late. So not much, right? You turn in a day late, that's 95. Turn 2 days late, that's a 90. With the maximum penalty of 50% of the points, because some of the assignments, they are, most of them are worth 100 points, some are worth more than 100 points. So the maximum, so you can always turn in something for half credit, no matter how late it is in the semester. Late grades, those late grades are determined when you turn them. This is important. I keep getting asked this every time, so I'm going to say it very loudly. Late grades for assignments are determined based on when you turn it in, not when you demo it. So you don't have to worry about demoing it by the due date. You turn it in, and I want you to demo it within 2 weeks of the due date. Now, the reason I have 2 weeks, now I say in the syllabus, you have 2 weeks until after the due date to demo your lab, otherwise it will be a 0. This will be waived for the most part. The reason I have this clause in there is that I also have I've had 1 or 2 students come to me at the end of the semester who haven't demoed anything and say, I just never got around to doing it. And that's a very, very painful experience, because most of the times, if you haven't demoed all your assignments all semester, that means we didn't get the chance to, point out any mistakes and tell you to go back and fix them. And then now the program doesn't work and you don't get credit for them. And so this just saves me a lot of time and agony. So I have this in here so that if you don't do all your, I have this in here for bad faith actors. If long as you're like keeping up to date with the class and you're a bit late or you're a week or two beyond this, you know, I'll accept the work. It's fine. Okay. So don't, you know, panic about it. This clause is in here for, again, people acting in bad faith. Okay. So again, the instructions are there. Again, it is important to let me know if you're struggling to complete a lab assignment by the due date. I'll be honest, I have been that student. I was a terrible freshman and sophomore student, like so bad. We're talking C's and B's here and a couple of D's for good measure for my freshman and sophomore year. Mainly because I had no work ethic. I thought, okay, yeah, 4 hours right before the deadline, that's totally enough time to do my programming assignment. But no, what you do want to do with the programming assignments is start them early, give yourself a bunch of lead time, not necessarily because you need to work on it, but because you might get to a stuck point, and it's good to sometimes sleep on that, or be able to get the opportunity to ask the professor, hey, can you help me fix this? The most frustrating thing one of the most frustrating things you'll experience in this class is you'll come up with some kind of bug in the program, okay? And you'll pound your head against it for like an hour, 2 hours, doesn't matter, or more, depending on how stubborn you are, okay? And you have no idea how to fix it. Then you'll bring it to me and I'm like, aha, I see your problem right here. Tap, tap, tap. It's fixed now in 5 seconds. And it's gonna feel so demoralizing, and you're gonna feel like a freaking idiot. You are not an idiot. You are human. First off, you were tricked by the fact that your eyes are not really meant for writing code. They're meant for, you know, avoiding danger. They're very good at avoiding danger. Not so good at the details of stuff. For instance, there's a deliberate grammatical typo in my teaching statement. See if you can find it. It's a very interesting one. But the point being is that your eyes play shortcuts and they will trick you. So being able to, you know, look at it again under fresh eyes is good. But the other thing is that this mistake I will have corrected is a mistake I've made myself 50 times or something like that. And not only that, I've like corrected, you know, over, you know, I think now a decade's worth of students in terms of just fixing this specific error. So I've had a lot of experience of getting stuff wrong, and that allows me to fix it and make it right. Don't try your best to to have some compassion for yourself in these circumstances. You're gonna mess up. That's part of the learning process. Okay. So this is where I differ from pretty much any freshman course, in the sense that we do have a final project. We also have a final exam, but I'll get into that. But you're like, that's unfair. A final project and a final exam. Well, the thing is that Intro to Computer Science, I get basically all the requirements for this class done like by week 10 or 11. And then what I would teach is kind of like up to me. I could teach you about more advanced topics, but you'd have that experience in later classes. And a lot of people I would teach would forget that stuff anyway. So instead, for that last month or so, and it is generally a month, I let you choose a final project. There's no more homeworks. There's just the final project for that month. And before you start getting scared, the vast majority of grades for that have been A's in the past. This is something, because this is a freshman course, right? Now, for a senior design project, we want it to work. For a freshman project, we want you to make a mess and see how far you've come. If it works, great. If it doesn't work, have you learned something? Great. That's what I care about. What I'll constantly say about the final project is that what I care about is the journey, not the destination. Okay? So I want you to learn something new that you normally wouldn't have a chance to. Are you interested in games development? This is your excuse to learn Unity or Unreal or some other games framework in a class and get credit for it when you normally would have to, you know, make yourself learn it. Do you want to learn how to build a website? Great. This is your chance to learn HTML, CSS, as well as different frameworks for making a responsive Web 2.0 website. What you do is up to you, subject to my approval. And generally the approval is to make sure it's not too small of a project. You can implement this project in any language. So you're going to be learning Python. A lot of you will want to stick with Python, but you don't have to. And in fact, you'll find that once you've learned one programming language, it's not too hard to pick up another. You're welcome to use any infrastructure, provided I would be able to recreate it myself. That's not like something proprietary that you have access to because you work for a company. All that we ask is that you build something that interests you, something that solves an actual problem, something that impacts campus, or something that would change the world, even if it's a very small way. I've had some of the more mundane projects have been people writing programs to help them complete their engineering homework. Silly games, Flappy Bird clones, visual novels. That's actually one I highly recommend because Python has a great framework for those, and doing choose your own adventure novels or visual novels are a great way to kind of make it creative. This is optionally a group project. You get the option to work in a group of 1, 2, or 3 people. It's your choice whether you want to team up or not. The more people you have, the more the more effort I'd expect. Okay. So I don't allow more than 3 people for a final project, so keep that in mind. But that being said, you're allowed to have an idea that somebody else had. If you both have an idea independently, it just means you both had a good idea. So the final project has 4 steps. And again, I'll go over this closer to the end of the semester. You have the brainstorming in GitHub. In other words, we have something called the proposal that you fill out. It is basically just a brainstorming. And we teach you how to use GitHub in the lab. Okay. GitHub is a website that acts as a great way to store code and share code. Git is kind of the de facto professional standard for sharing code these days. Then the second part is the proposal, where you tell me what you're going to do. This is on the due date of that proposal. I'd usually dedicate that lecture period to meeting with everybody, albeit whether it's in person or over Zoom. And I meet with everybody and give you the okay on your final project, or I suggest something in the appropriate scope if I haven't done so already. That way I can just make sure that's good. Generally a week or week and a half before, you give me a progress report just so you can temper your own expectations. And then you have the final project, which is you show me your code and you give me a video walkthrough of it. And by video walkthrough, I mean like 2 or 3 minutes just showing off your program, not the code, the program itself. Okay. The final project and all parts of it need to be on GitHub. I mean, the video doesn't have to be on GitHub, but you certainly want to link to it from GitHub. But not doing it on GitHub is a 0. GitHub isn't scary. There's a lot of desktop environments that you can use it. Also, I have these clauses in here not to be mean, but because it saves me a lot of time with students who again are acting in bad faith. If you've not turned in the proposal by the time the progress report is due, meaning if you haven't turned in a proposal by the week before the final project itself is due, we're just going to mark that final project as 0 because there is not enough time in a single week during the final week of school for you to catch up on. It's just not. You have other classes. So, and it means that at that point you weren't communicating with me. I mean, obviously, if you're having a medical kind of thing, right, all this is subject to change. The due date for the final project is going to be a hard deadline. The due date will not be altered for any student without prior approval, accommodation, or a sudden and documented emergency or event. I don't really care about documentation for any of the other stuff. For things for hard deadlines, I mean, they are hard deadlines. This is because the due date for the final project will be is the last day of class, and by university policy, I cannot make anything due past that date, right? It has to be that last day of class. There's a late penalty for it. It's 1/10 of a point per minute. So if you turn it in an hour late, 6 points off. Don't be intimidated by the scope. Again, I've said that it's all about the journey, not the destination. It's meant to be a learning experience, not a tech startup. Again, what I care is, have you learned something? That's what if you've learned something, you're probably getting an A. My general rubric is, does it amuse me? If so, A. Amuse me, does it keep me amused for a minute? That's generally the time limit. So, and I am a very easily amused person. Now, what is the incentive for you to do well? Well, the best projects get to skip the final exam. There you go. So best projects get to skip the final exam. I don't care how big. So generally what I do is I choose 1 or 2 from each section, depending on how many courses. And if I generally try to do 1 from each section, but some projects, they're just so good. I can't, I can't choose between them. So, I don't. All right. And then this is more applicable to anybody who's in a senior class. Double dipping. You're allowed to double dip this final project. If you have a final project in like your senior class or some other class, and that you find, oh, I could totally do my programming, I could incorporate programming in this. You can do that. All you have to do is get approval from both me and the other professor, right? This is something generally double dipping isn't allowed, but once you, it's like that, like it's frowned against. But again, I have this in my syllabus. As long as you get approval from the other professor, that's perfectly fine. Okay. I have some back over here, frequently asked questions. I have partners. How does turning in stuff work? Just, you can all turn in the same thing, essentially. There's only needs to be one GitHub repo. There only has to be one account, but you should all link it to me. That just makes it easy for me to, when grading comes along, to differentiate between, people who completed the project versus people who didn't do the project. And typically what happens if you're part of a group, but you didn't turn it in yourself, you'll initially get a 0. You'll email me and I'm like, oops, okay, I'll fix it for you. And that's that. And this just saves time and stress. My project is not done and the deadline's upon me. Can I just turn it in later? No, turn in what you have. It's not going to be as horrible of an experience for you as you think it is. So what if I do if my work isn't done? Turn in what you have. It's not going to be as terrifying as you think it is. Again, journey, not destination. If you needed to get from A to G, but you only were able to do A, B, C, D before and E became a total just wall that you couldn't get past. Talk to me about that in the video. Tell me what you learned. I want to do Hangman as my final project. No. The version of that Hangman is the kind of the ubiquitous example of something that is way too easy for a final project. Now, a Hangman where the computer won almost every time because it's cheating and doesn't get detected in the cheating, now that's a good project. In fact, I do that as a homework in 2168. And do you have to get approval? Yes, please. I don't want you to accidentally decide to do Hangman and then get a 0 because of that. So exams, I'm rewriting this section. Last semester, I tried something called a 2-stage examination. I'm debating whether or not to do that again this semester. And that just depends on whether or not we're going to do our exams in lecture or during your lab sections. Now, in the previous semesters, all my exams have been spread out. All my labs have been spread out somewhere on Monday, somewhere on Tuesday, somewhere on Friday. But now I've just got Friday and Monday. And that's not too spread out. So what we could do, so there's a couple of different, so I'm still deciding on how to do these exams. And the way, let me just, again, this is part of where I like to actually have a actual discussion in the class. So first off, exams, I know they're super stressful. I'm trying to do 3 exams. Each would be worth 10%. That way they're not each too much of a huge stake. I try to also give you access to resources that you would normally have while programming. The issue for the first exam is I want you to basically give you questions about reading code. So, and I need to make sure that, so as the semester goes on and on, you'll have access to more and more resources to use is the point I'm making, but you'll always have access to notes, Make sense? So we can do these exams as normal. There's also the 2-stage examination. And this is for, what if it was done in lecture? If it was done in lab, it would be 70 minutes here. But what you would do is you'd take a first exam, you'd first take your exam in the first 2/3 of the class, okay? And then for the second, and that would just be as normal, it would count for 80 to 90% of your overall exam grade. And then for the second part, it would be a group exam. You'd split up into groups of 2 to 4, what was it? 3 to 4. There we go. You don't have to pre-organize yourself into those groups early on. You can do that at the exam. That's worth for the last remaining portion of your exam grade. The group exam is either identical or consists of a subset of the problems from the exam or a similar but new problem. And you would turn in the one exam for the entire group. Now, I know some of you are like, but working in a group is totally RNG. It's luck-based. What if I get stuck with a terrible group? So my guarantee is that no matter how I decide to do group work, because I do want to do some type of group work this semester, and this is one way to do it. Again, I got to figure out how I want to do this, and I'm open to suggestions. Your overall score will not be lowered due to group work. It can only be raised. So in the case of this, say you get a 90 on the individual portion and you got a 85 on the group portion, then what I would do after a few weeks, because I'd want to see to show you what you actually made, after a few weeks, I'd go in and change that group exam grade to a 90 to match it so that you wouldn't lose any points. Okay. So now why this nonsense of basically doing 2 exams on one day, an individual exam and a group exam, and I would make them allotted accordingly to the time period. The reason for this is because it kind of leverages the whole energy that a lot of people that occurs right after an exam, which is that you immediately go out of an exam and you're like, what did you get on this question? Did you get A? No, I got C. Oh, drat. Or did you, there's this eagerness to know what the right answers were. This kind of leverages that into a learning experience. If you got it right, congratulations, you get to truly master something by teaching it to somebody else or confirming what you knew. On the other hand, if you got it wrong, guess what? It's a learning experience and you get to immediately correct that mistake. That's what the idea is here. So I'm not sure how people feel about that. The only issue was that it was a heck of a lot more work for me initially doing the setup, but now I have group exams and regular exams. So we may just also do solo exams and then do some, in lecture and then do some group exams later, or do some group exercises that help you get points for your exam later. Might split it up, maybe not be on the same day. Because the biggest issue I have is the people who this leaves out, which is anybody who has an accommodation. Right? If you have extended time, then it suddenly becomes a bit more difficult to participate in this. So again, regardless, the other thing is that the other issue I had with this is that it has a strict pencil down time, right? Once the time limit happens, that's it, right? You got to turn in your assignment. For my exams, I don't like that. So this is why I'm torn, because there's 2 very good reasons. There's the whole very strict time limit, and there is the and there's the fact that that some people would get left out due to accommodations. So again, feel free to hit me up on Discord about this. If you have suggestions, I'll let you know. Now, typically the first exam is on week 6, the second exam will be sometime after that. So I try to do them every 5 weeks or so. Okay. Now here's what I do guarantee. You will know that you are getting an exam at least a week in advance. You will get practice problems for those at least the first 2 exams. Okay. And the final exam is just going to be another exam. So your 4th exam for the semester, it's just worth more and cumulative. That's all. Not all points are equal. So points for one category only belong to another category. So now that you have a chance to digest that, what are people's opinions, just initial opinions on doing group work for exam grades or individual stuff for exam grades? What are people's opinions on this? Yes, no? Yeah.
I like it because it gives you a chance to bring up the grade after you've already learned it a second time for like group exams.
It's a good point. Other people? Yes.
I'm fine with it, but it just seems like, I don't know.
A little
Weird.
weird. It is weird. I'll give you that. I tried it last semester. It was experimental. The overall consensus from students and I'll get to you. I saw your hand. The overall consensus from students last semester was that they liked it. But we did have an issue with exam 2 where I overestimated the difficulty of exam 2. Underestimated the difficulty, and it was just way too many problems for the time period that they had. Yes.
A lot of interviewers ask about 500 different, especially in consulting, this is a good opportunity, I think.
It's a good point. Now, again, if we do decide to do this and you cannot do the group exam portion because like you had to take it a different day or something like that, again, all I'll do is just replace your solo grade, your group grade with the solo grade, right? The group portion can't hurt you, okay? Okay, so again, I'll have an idea of whether or not to do this by next week, okay? So you will know. Okay, and please, if you want to talk about this, talk about it in Discord. Okay. The last part is, how does academic honesty work in this class? Like, you kind of understand how plagiarism works for like literature papers, right? Don't copy and paste. Don't like just copy it and try to reword it. Don't try to, copy it and throw it through one of those spin bots. That's generally frowned upon. You're supposed to do your work yourself. But I really want you to collaborate. As was mentioned by you really want to work with other people. It's one of those skills that's really important in computer science. And I really like that collaboration. The true path to mastery is by teaching things. So I want to make sure that I kind of give you so let's talk about the general rule of thumb. Okay, generally speaking, if you're the person asking for help, you can share your code with other people. If you're like, okay, I don't know what's going wrong with this block of code, and you paste it on Discord, that's great. Awesome. That's exactly what I want you to do. If you're the person having trouble, feel free to share your code with others to ask for help so that they can help fix it, so that they can help teach you. If, on the other hand, you have a solution, you should not share your solution with other people. If you're the person trying to help someone else, don't share your code. You're allowed to give out pointers and stuff. The only time I think it's like appropriate to share completed solutions is with other people who have their own completed solution, so you can compare notes, Okay. So generally speaking, when asking for help, you can show your codes to others, but don't view theirs. Okay. So if you're having trouble, this is very important here. If you're having trouble completing an assignment, send me an email and I can arrange, and so we can arrange a time so I can walk you to a path to that solution, help you get through whatever barrier you're running up against. Okay. Don't go to Chegg unless you want to fail that course and get an academic misconduct charge. Okay. Don't just go to ChatGPT for a solution either, because it might spit out something that you don't know how to explain and you won't be able to demo it. And then also you won't be able to use ChatGPT during the exam, which is a bit tricky. Now, on the other hand, ChatGPT, if you share ChatGPT your code with it and say, hey, can you debug it? Ostensibly, it can do that for some cases. And I'm okay with that. I mean, that seems like a legit use, but asking it to complete some of the assignments, that's reducing it to somebody else doing your work for you. Although in this case, it's something else doing your work for you. Anyway, so here's kind of an idea of what actions are reasonable. Okay, versus what's not reasonable. Communicating with classmates about the assignment, helping a classmate identify a bug by either doing it in person or online, by viewing, compiling, or running their code. Even if it's on your own computer, you're allowed to have other people's code on your own computer. This is sometimes a very hard line for other professors, so be sure to ask them. But for me, Again, it's, if you're the person who's, if you're trying to help somebody else, it's perfectly fine to see their code. Okay? Sending or showing code you've written to someone else, possibly a classmate, so that they can help you identify and fix a bug, provided you cite your help. This is generally a safety thing in case your code ends up really resembling theirs, right? So if you work with Alice Awesomeface, then I want you to just give me a comment saying that Alice Awesomeface helped you with your code. And this helps prevent any misunderstandings. Okay. Incorporating a few lines of code online or elsewhere that you find online that don't complete the problem for you, but help you complete a small part of it. That's perfectly okay, provided you cite it. So an example of this is that I have a question in 2168 that says, hey, here's two lists, detect whether or not they're permutations of each other, meaning are they made of the same items, but in different orders? Okay, and some students figure out, wait, if I sort both these lists, I can figure out, I can just see if they're equal, and then they're permutations of each other. So then they say, okay, what is the built-in way in the programming language I'm working on to sort something so I don't have to write the sorting algorithm myself? And then they typically will, and that small part of it, the sorting it, they'll typically find online and they'll cite it. That's perfectly acceptable. Notice how it's a, you know, a noticeable chunk of that problem, but it's not the entire problem. Sharing a few lines of your own code online so other people can identify and fix a bug. Turning to the web, you know, Googling for certain issues or crashes or errors that you might have, or for solutions to technical difficulties, but not outright solutions. That's perfectly good. Writing stuff on a whiteboard with other students, that's great. Working with and even paying a tutor to help you, that's great, so long as the tutor isn't doing the work for you. Okay, not reasonable. Accessing a solution, you know, before you submit your own. Asking a classmate to see their solution before submitting your own, right? Before submitting your own. Afterwards, that's, you know, that's way more, you know, reasonable. Failing to cite the comments. For example, copying and pasting code you find from a site online, it's kind of trivial. If I suspect you copied it, I could just, you know, throw it into Google and get that website up. Finding a code online that addresses a question on an exam and failing to cite it. This is back when I allowed people to use Google for some exam questions, would violate the policy. And then finding code online that you think might address the question and just copying and pasting it blindly and it's the wrong answer to the wrong question. Yeah, that's very bad. Showing a classmate the solution to a problem when they're the one struggling and not you. Paying somebody else to do it for you. Searching for solutions like on Chegg or something. And this one's more common, which is that, you know, if I give you a problem that has 8 sub-problems to it that are independent, you say to your friend, I'll do the evens, you do the odds. That's not cool. You know, you're missing out on half the learning experience there. I know it's a lot, but I mean, again, if you're working together on this, that's great. But like splitting it up, you know, working on these problems independently of each other and then compiling them like that, that's not so great. Submitting, you know, getting the answer from somebody else and then just changing a couple variables and putting your name on it, no. Submitting the same or similar work to this course that you would submit to another course without approval. So going back to that whole double dipping thing. And then, you know, just again, viewing somebody else's solution. Now, that being said, and this came up last semester, if you committed an act that was under the not reasonable thing, and I haven't reached out, I haven't detected it yet, right? If you reach out to me and said, Professor, I messed up. If you're open and honest with me and said you made a bad decision within 72 hours, I'm not going to refer that to academic misconduct. Okay, I'm not going to auto fail you. We're going to figure out what the appropriate sanction is. But that will prevent you from going to academic misconduct, which is not, you know, we will not refer the matter for further disciplinary action, except in cases of repeated acts. So in case you've done this like a bunch of times, you know, a disclaimer, I could change this syllabus will change, especially the exam portion of it. And you have rights and responsibilities. There's the link to them. For instance, you have the right to You have the right not to take 3 finals in one day. You have the right to take only up to 2 at most in one day. So it's fun things that you can discover about what you're allowed as a student when you read that stuff. All right, I know that was a long syllabus. I'm sorry that it drained on for so long. I just have a lot of details about the class about what I want to explain. So, yes,
How do you cite something? Like, I don't-
in a comment and give me the URL. It's not MLA or anything like that. I'm not, I don't even know how to do MLA or Chicago at this point. I just throw it into BibTech and the bibliography manager and let it handle it for me at this point. I mean, all right, so this is what our textbook will look like. It's electronic. I'll go, there's a video on under modules that goes over it. But over here is where you'll find assignments when I open them up. I'll be doing so tonight. But in general, even if you don't see that, you definitely want to try to read chapter 1, for this week, which talks about just kind of the Python programming language. And what's really cool about this is that we can run Python in this book. You get, you'll see little blocks of text that you can hit and it will run it and execute it. Not only that, you can change it. Here, just doing some basic math, 2 + 7, that's 9, right? And then not only that, it saves everything you do, not to your local computer, but to online, so that no matter where you are, you can refer to it. It also helps because I can refer back to things that you've done. All right. It will keep track of what you've read and generally to what you've interacted with in the page, so you can get credit for it. It's overall an excellent book. On Thursday, what we're going to be doing is we're going to be doing this first project called a preview of the end goal, which will be running Python programs, pretty advanced ones at that, even though we don't know anything about Python yet. It's more of figuring out what code does based off of little things we're able to pick up just by, being adults who can read. So that's what we'll do Thursday. In your lab, the point of your lab will be, so your lab, be it on Friday or Monday, that lab's objective is setting up your Python program. Setting up the Python programming language. Now, I know some of you might be concerned because we didn't have a Monday, okay? The way to think of this course is that it's not Monday, Tuesday, Thursday, or Tuesday, Thursday, Friday, but it's Tuesday, Thursday, and then you have a following lab on either the Friday or Monday, right? So the labs always come after the week's lecture, okay? Make sense? So lab 1 will be on the second week for anybody who's in the Monday labs. So that being said, feel free to access the lab and start it if you want to. If you want to get a head start, you can do that for any of the labs. If you are having trouble with setting up Python, that's definitely something we want to get addressed early. So meet with me, send me an email. I can meet you over Zoom to help you get to handle that. All right. Okay. Any other questions before I move on? All right, enough administrative stuff. Let's get to teaching. All right, so in terms of computer science, it is both a old degree, it is both a very old subject field, but it's also a very new degree. We didn't really offer any computer science degrees for, I don't know, I feel like the 50s or something like that. But let's see, is it in here? No, it's in, went to the wrong place. Classroom, ITP. Oh, one. Nope, that is a example of how to run a program. Yep. Sorry, hold on a second. I know I have my lecture 1 notes in here. Somewhere. Oh, okay, they were there the entire time. Of course they were. All right, so you're in this computer science class and you're either in a computer science IST major or data science major, or you're taking something that you're interested in this field, or you're in a degree that requires you to take this class. So what is computer science? It's kind of an important question. We should probably know that before we go and teach computer science, because there's a lot of misconception about it. There's this quote here: computer science is no more about computers than astronomy is about telescopes, right? We don't call biology telescope science. We don't call astronomy, we don't call biology microscope science. We don't call astronomy telescope science. It's not about the tube. It's not about the tools. It's about what we do with them and how we use them. It's also not programming, although we do a lot of programming in computer science. That was my misconception, that computer science is like the study of programming, but it's not. Isn't also about fully learning programming languages. It existed at kind of as a field before we had our programming languages. Besides, by the time you get a degree in computer science, or by the time you actually end up this class, it's not going to be too hard to pick up any language, right? It's about, after you get a degree in this, it's about like 2 weeks to learn a lot of stuff in the language. But even then, even if you don't have a degree, it's not too hard to pick up another language. So I find, so there's a lot of talk about what is computer science, but here's a not wrong definition for you. Something that basically, if you said that to somebody else who was in the field of computer science, they'd go, yeah, that seems like a good definition. Gibbs and Tucker, they give a very simple definition of computer science being the study of algorithms. We ask basically what can be automated. That is what we are studying. In other words, we're studying how can we basically, kill every job that there is out there. What when you can get down to it, can be automated. And the answer is lots, but not everything. It covers a wide variety of topics in theoretical computer science, and this is just the theoretical stuff. Covers algorithms, data structures, computational complexity, parallel and distributed computing, probabilistic computation, quantum computation, automata theory, information theory, cryptography, program semantics and verification, machine learning, computational biology, computational economics, computational geometry, and computational number theory and algebra. And that's, again, just one small part of it. So we study algorithms, and I will define those in a bit. We study algorithms to determine if they are correct and efficient. In other words, do these work, and how well do these work? We study how to build systems that can implement these algorithms. In other words, we study computers or some other hardware realization. We design programming languages so that we can actually implement our algorithms very easily onto these, rather than, because what we have with algorithms are these abstract mathematical things, and on a computer, we've got something a bit more defined. We've got a language to describe those. So, and let me go ahead and, before I move on to what you can do with computer science, let's talk about what an algorithm is. So algorithm comes from the Latinized name of Muhammad ibn Musa al-Khwarizmi. I probably butchered that name. It was Latinized to algorithmy, and he wrote a textbook called The Concise Book of Calculation by Reduction in the year 820. He was a Persian mathematician, I should point out. And from his name, we get algebra. From that book, we get algebra, because the algebair, meaning reduction, was in the title of that. So the entire idea of doing algebra with these numbers were well, here's what it says. He wrote a book containing formal instructions on how to do mathematical operations with a relatively new Indian decimal system, which was a lot more efficient to work with than like the Roman numerical system, a lot better for working with numbers. So eventually that was translated into Latin in the 1100s, and it spread like wildfire. So an algorithm, which is named after him, is a set of well-ordered, unambiguous operations that yield some finite result in a finite amount of time. So let's go through all those icky terms one by one. So what is well-ordered? That means that that an algorithm is made up of steps that you do in a specific order. You have step 1, step 2, step 3, etc. You don't do just the steps willy-nilly. Okay, unambiguous, meaning that we can't confuse them, right? A lot of recipes are algorithms, but some of them are not, where they say like a pinch of something. What the heck's a pinch? A pinch is very ambiguous as to what that is. We need unambiguous. It yields some result. It does something. It does something. So the algorithm actually has to have a purpose. It's not just going to do nothing. It has some result in a finite amount of time, meaning it's not going to run forever. It's not just going to, there's an end point for an algorithm. Okay, you've learned some algorithms yourself, addition and multiplication by hand, right? Anytime where you've had to do the addition where you're adding 2 digits and then carrying, that's an algorithm that you've been taught. That's one that you know. That has very specific steps, and the algorithm doesn't work if you don't go from the 1s to the 10s to the 100s. If you do it from the 100s to the 10s, it gets all messy, right? Similarly, doing long division by hand or figuring out what the greatest common divisor is for something. Those are algorithms. Algorithms, the point of them is to turn them into a program to allow the computer to automate some task. That's it. It's about as abstract we're going to get in this class. So what can we do with computer science? So obviously, right, there's software development, writing programs and stuff. But again, this class, I get a lot of students who are not computer science, who are not computer science majors. What can you do with computer science otherwise? Well, biology, chemistry, and medicine. Bioinformatics, that's the term for it. In other words, biology plus informatics, which is the term that is used for computer science in not America. It's a really big field, and it will never stop being a big field. Figuring out how proteins fold and interact with various things. Figuring out how writing programs that help analyze DNA. Medicine, prosthetics, robotic enhancements to people's bodies. Cancer detection, HIV, development of HIV inhibitors. There's a huge list of things that are not just, big, but really big in computer science and biology. This is covered by both biology degrees and also the data science degree with a emphasis in biology, the concentration of biology. Physics and astronomy, quantum computing, supernova detection. That's a big one. Actually, most supernova these days are detected automatically by computers analyzing telescope images, not by eye anymore. It's an automated task. The Large Synoptic Survey Telescope is expected to gather about 140 terabytes of data a day. You got to sit through that all that information in astronomy in order to detect stuff. Also, algorithms to detect exoplanets. That's a big thing that we've only relatively recently, in the past decade or so, been able to do with any accuracy. Detecting planets outside of our solar system, in other solar systems. That's huge. Doing engineering. If you're more interested in the literal money side of things, there's always high-speed trading algorithms. In fact, there's been a couple of micro crashes and flash crashes that were caused purely by bots trading online. Yay. But also a lot of the trading these days is done by algorithms, done by automated processes. Okay. Psychology is also a really big one where you can actually have a real direct impact in people's lives. It's the cross-section of computer science and psychology is called human-computer interaction. So things like that, developing user interfaces, figuring out devices and ergonomics for computers, figuring out how your website is more efficient, or on the darker side of things, how to keep them scrolling forever on your website, how to make sure they keep getting that dopamine hit, right? So there's both good there and, a bit more of a darker design pattern, we'll say. Education. Ever played Oregon Trail or some other educational game? Where in the world is Carmen Sandiego? Heck, I'm playing an educational game right now. Learn Kanji to Survive, which is a RPG where you memorize kanji. So gamification of things to learn how to do these things. It's huge. Games are great ways to teach. also just, straight up making education more accessible by making resources online. That's great. More direct applications of CS are software engineering, networking, data analysis, and security, those kind of things. But so in the last 10 minutes, how in the world did we get here? Well, brief history was, we didn't really have, as far as we know, we didn't really have anything more advanced than the abacus for a couple of millennia, which is not a computer. It's just simply a way of augmenting a human to help them do data, storage, to help do larger and larger mathematical operations. But between the 1600s and 1800s, various engineers in different parts of the world, and I've got specific names here that are European because I'm not too familiar in other parts of the world, but various people, it was kind of in vogue to propose these gear machines that had these turning gears that would do these automatic operations. The positions of the gear would represent the numbers, and Babbage in specific wanted to create a gear-based machine that could print out the output on paper. So you would turn and then you wouldn't have to look at the gears. It would, print out that result in some way to use. Which brings us to the first programmer, Ada Lovelace, or Ada, sorry, let me go ahead. Augusta Ada King, Countess of Lovelace. She is widely credited to be the first actual programmer, because nobody can really come up with a better solution for one, and because she actually wrote an actual program. So for those of you who don't know, she was the daughter of Byron, Lord Byron, and if you've done your world lit, you'll know he was a very contentious figure. His divorce with his wife was so the topic of that time period that people were fighting over it and who was responsible, and long after both parties involved were dead. That is how explosive of a figure he was. He was very temperamental, and so Ada's mother basically directed her to pursue much calmer subjects in literature, like mathematics, which eventually got her in touch with Babbage. So Babbage had this idea for this analytical engine that he designed but never produced. It would take instructions from a paper card with holes punched in them, and Ada published. She translated a paper, but then also added notes and published it herself, which showed how this analytical engine could be used to compute Bernoulli numbers, which are these interesting series of numbers that are non-trivial to do by hand as they get much larger. But so you can find her original paper online where she proposed this program for this, theoretical machine that didn't even exist yet. But not only that, she had an idea about 100 years ahead of her time, which was that you could use this machine or a machine that was similar to this analytical engine that would work on things other than numbers, like letters. This was an idea that didn't come for yet like another 100 years after that. Sadly, she was struck down by cancer in her, I think, late 30s. And so basically hundreds of years had to wait, unfortunately. The next big jump in computer science came around World War II with the birth of modern cryptography. In other words, breaking codes. You've got commands, you want to keep them secret from the enemy. And if you've intercepted enemy's commands, you want to translate them so you can make them dead before they make your people dead. It's war, unfortunately, and it's brutal. And there's no such thing as fighting fair. So the ciphers were both used against the Japanese and the Germans. The Japanese ciphers were much more easily cracked than the German ciphers. The project to extract intelligence from German encrypted commands and communications was led by a team at Bletchley Park, Alan Turing being the most famous member of that. And the intelligence they got from cracking those codes, which is its own lecture in itself, was decisive. Eisenhower said it was decisive to an Allied victory. He estimated that it shortened the length of the war by about 2 years. Okay. Alan Turing, unfortunately, had the misfortune of being born gay in a time where that was not allowed. And once he was outed for being gay, he was given the choice to either be chemically castrated or go to prison. He chose the former and later committed suicide. Again, at a very young age, relatively speaking. And the British government only in like the past decade apologized for this like utter travesty. So yeah, that's 2 people who were early in computer science that are total downers of an ending, unfortunately. Fortunately, past that, there are less downers of endings. But it is important to keep that in mind, that there are a lot of people who were involved in computer science. These are just 2 names that are early. Now, the first computer, there's no clear contention. It's contentious. There's no clear first. There's a whole lot of proposals. I like a famous one, I would say, a famous early computer, one of the very first, is ENIAC, which is the Electronic Numerical Integrator and Computer. Construction began in 1943, completed in 1946. It looked like this. Took up an entire room. Wires had to be manually done. It was used for artillery calculations. Nowadays, this is a computer. You carry it around with you and barely even think about it. And that has been basically the name of the game since ENIAC, which is that computers get smaller. 1851, home personal computer. In other words, one that you could have in your home. A person could have it. It was for a person. They would get smaller and smaller, and then they would get more and more connected. The internet. Tim Berners-Lee proposed the World Wide Web, an application of the internet where websites and documents link to one another. The web is so large that it requires search engines to sift through all the websites to find the useful things out there. Smartphones are big. Again, miniaturization and scale. The world gets more and more connected, and things keep getting smaller. And it's very easy to take it for granted. I mean, in my lifetime, I went from just to go from a more amusing note, I went from the NES, and now my kid's playing on a Nintendo Switch. I mean, that is leaps and bounds in terms of technology there. I mean, think about the original Super Mario versus Super Mario Odyssey. Very big difference between 2D side scroller with very limited memory, very limited 4 channels for music, versus a full 3D game, which is multiplayer, able to be either portable or displayed on a TV, and with a full orchestral soundtrack. It's a huge difference, and it happened in my lifetime. It is huge. So with that, I want to just simply say, leave you with this last thing. How do you become a good programmer? The answer is practice. Nobody's born being a good programmer. It comes down to being able to practice. You got to be able to practice. And as we'll talk about later, you got to be a special sort of lazy. The kind of lazy who says, I'm going to do this hard thing right now so I can be lazy forever. All right. So if you've got any questions, feel free to come up here and speak with me. I've got plenty of time. And otherwise, I look forward to seeing you on Thursday.